We're going to continue looking at the Chapter 4 practice tests for the multiple choice questions, particularly 5 through 8. Number 5 says, consider an experiment to investigate the effectiveness of different insecticides in controlling pests and their impact on the productivity of tomato plants. What is the best reason? This has got to be the best one for randomly assigned treatment levels, spraying or not spraying, to the experimental units of the farm. Before I read the choices, I'm going to look at this prompt and maybe it'll help me in a future question. It's helping me identify what are treatment levels in an experiment, and it's helping me identify what would make up experimental units. So we can sometimes use previous prompts to help us remember certain definitions to terms. So choice A, random assignment makes the experiment easier to conduct since we can apply the insecticide in any pattern rather than in a systematic fashion. Now I'm going to disagree with this in two places. One, I don't think conducting an experiment is going to be easy to do. I mean, you have to have control. You got to have a random assignment. You got to have replication. You got to make sure you take care of any lurking or confounding variables. There's a lot there. So the word easier kind of stands out, but particularly the phrase that stands out is, hey, we can do it in any pattern we want. And that's not what random assignment is. So I don't think it's A. B says random assignment will tend to average out all other controlled factors, such as soil fertility, so that they are not confounded with the treatment effect. I like this one, and I'll come back to why I like B. I don't know if it's a choice yet, but we'll come back to it. Random assignment makes the analysis easier since the data can be collected and entered into a computer. Just marking that wrong. Random assignment has nothing to do with putting the information inside of a computer. Random assignment has nothing to do with making it easier to collect the data. Random assignment has to do with really what choice B is. It tends to average out all the other uncontrolled factors that we're not aware of, any lurking variables. It tends to average them out in the treatment groups for it. So that's why I like B so far. D, random assignment is required by statistical consultants before they will help you analyze the experiment. Then which is the best answer? That's not it. Random assignment implies that it is not necessary to be careful during the experiment, data collection, and during data analysis, which is completely wrong. I mean, if we look at why we use random assignment, it is choice used. You want to average out all other control factors, any lurking variables that could have effects on the treatment groups. So the answer for number 5 is B. Number 6, the most important advantage of experiments over observational studies. This is huge. Very important question for us to understand. And the phrase that should come to mind when I think of this is, why do we do experiments over just observational studies? And that is because of cause and effect. That is a huge benefit of experiments over observational studies. So when I'm going through choices A, B, C, D, E, I'm leaning towards B. I see experiments can give better evidence of causation. So let me just read the other choices just to make sure there wasn't one that's phrased even better addressing the same situation. Experiments are usually easier to carry out. No. I mean, there's a lot of detail that goes into experiments with it, with the controlling, identifying any variables, look at variables that can go in there, randomly assigning. There's a lot that can go into it. Confounding cannot happen in experiments, and that's false. We try and reduce the impact of confounding and looking variables on it. They can still happen, but we try and spread it across by doing random assignment to the different treatment groups. An observational study cannot have response variable. That's wrong. Think about back in chapter 3 when we looked at stuff like that. Observational studies cannot use random samples, and we can do random samples in observational studies. So B is the choice. Number 7. A TV station wishes to obtain information on the TV viewing habits in its market area. The market area contains one city of population 170,000, another city of 70,000, and 4 towns of 5,000 inhabitants each. The station suspects that the viewing habits may be different in larger and smaller cities and in the rural areas. Which of the following sampling designs would give the type of information that the station requires? So if I'm thinking about what's given to me, I'm told there is one big city, 170,000. We'll call the other one medium city, 70,000. And there are 4 small cities. Small city 1, small city 2, 3, and 4. And I want to know, if I'm part of this TV station, what design should I use? Well, each of these cities, they are different sizes. They can have different people. Some of them are in large cities, some are in small cities, some are in rural areas. So we have to figure out which one to do. If I were to design this experiment, I would want to make sure that I got a good amount of information from this city. And I know, what does a big city look for? What type of viewing habits do they have? And I want to, what is a medium city? You know, if it's a medium city, are the viewing habits different than the big city? I want to know that as the TV station. And the same with the small. Could it be a small city? Could it be in the rural areas? So I would separate these based off of what they have in common. I would keep the big city by itself. I would keep the medium city by itself. And depending on, now I need more information, maybe I'm just going to group all the small cities together if I see that they have a similar characteristic or trait together. Or maybe if I see that 2 of them have a similar trait. These 2 are rural, these 2 are suburban. You know, then maybe I'm going to group them that way. But do you notice I'm grouping them based off of something they have in common, a characteristic or a trait that they have in common, which tends me to think that I'm doing stratified random sampling for these. And is D. I'm not going to do convenience sample, which is choice B. A simple random sample would take all of these cities, all the different sizes, and it would put them into one group. And it would collect just randomly from that group the people for the sample. And by doing that, I mean, you might underrepresent the small cities. I might get most of my people from the big city into the sample, a few from the medium, and just a little from the small. Might underrepresent the small cities on it, or vice versa. I mean, I could grab randomly assignment, might make it, since there's 4 small cities, maybe, you know, I'm going to get a lot from this area and very few from this area. So a simple random sample, pooling all these cities together into one group and then randomly assigning, not a good move. An online poll doesn't work. So now it's the idea, what's cluster versus sampling, cluster sampling versus stratified sampling on it. And I think I look at this and I go, I'm doing stratified if I break them into similar traits on it. Number 8, bias in a sampling method is. So this looks like it's a definition. We need to figure out which is the best definition. It is any error that in the sample result that is any deviation of the sample result from the truth about the population. I'm going to leave that one. I'm unsure. So let's just move on and see if I can do some elimination. The random error due to using chance to select a sample. And that's not true. When we use randomization, we try and reduce bias. It's not going to completely go away. We're trying to reduce it. So no, it's not B. Any error due to practical difficulties, such as contacting the subject selected. Now that sounds like a type of bias that we've discussed. It's not bias in itself. I mean, C is actually giving us a type of bias. Any systematic error that tends to occur in the same direction whenever you use the sampling method. I'm going to mark that one. Racism or sexism on the part of those who take the sample. Again, it's describing a type of bias that it can occur. It's not giving me the definition of bias. So it's either A or D. So if I were to think about bias, I would think about the definition that we said, that it systematically favors certain outcomes. That is the definition of bias. It systematically favors certain outcomes. You could be really tempted to choose A because of, I would say, how well it's written on it. You tend to lean that direction. And even when I'm going through it, I was reading it, and I put a dot next to it, that has me thinking. But before I select anything, I'm always going to read the other ones to see, is there a better one on it? And it is systematically favoring certain outcomes when we're sampling for it. It's going to be a definition that we need to apply. It's going to be choice D.